2.2 Practice Problems, page 53, Evens. This lesson was about using the multiplication rules for algebra problems that involve multiplication. Alright, starting with the top. 3x equals 21. Remember, I'm just walking you through the thought process for these things. Our goal is always to get the variable by itself. 3 times x equals 21, and we start by rewriting and resaying the problem. 3 times x equals 21. How do we undo multiplication? What's happening to x? It's being multiplied by 3. How do we undo multiplication by 3? Divide by 3. What we do to one side, we got to do to the other. 3 divided by 3, they cancel. We're left with x. 21 divided by 3 gives us 7. 1/5 x equals 7. What's happening to x? It's being multiplied by 1/5. How do we undo multiplication by 1/5? That was a pause. So how do we undo multiplication by a fifth? Well, we can divide by a fifth, which might be kind of difficult, or we can just use reciprocals. Reciprocals are usually the way to go. That was a pause again. Reciprocals. So reciprocals just means we flip and multiply, and that works the same as division. So flipping 1/5 gives us 5/1. We'll multiply. What we do to one side, we got to do to the other. These things cancel. We're just left with x. What happens to the right? Well, that 7 is the same as 7/1. We just got 3 times 7, which is 35. -2 times x equals 18. How do we undo multiplication by -2? We divide by -2. Cancel, and the negatives cancel too. What we do to one side, we got to do to the other. 18 divided by 2 is 9, plus that negative gives us -9. 3 times x equals 8.1. How do we undo multiplication by 3? We divide by 3, cancel. What we do to one side, we got to do to the other. 3 goes into 8 twice with a remainder of 2. 3 goes into 21/7, plus that decimal gives us 2.7, but you can check my work. 4 times x equals 2/3. How do we undo multiplication by 4? We divide by 4. What we do to, well, since we have a fraction involved, let's use reciprocal. So instead of dividing by 4, we'll multiply by reciprocal. What's the opposite of, what's the reciprocal of 4? It's 4/1. What's the reciprocal of 4/1? It's 1/4, so we'll multiply by 1/4. What we do to one side, we got to do to the other. Cancel, cancel, we're left with x. 2 and 4 both have a 2 in common. Divide by 2 gives us 1. Divide by 2 gives us 2. 1 times 1 is 1. 3 times 2 is 6. 0.075 equals 1/5 x. What's happening to x is being multiplied by 1/5, so we can multiply by the reciprocal to undo that. Cancel, cancel, we're just left with x. What we do to one side, we got to do to the other. That's the same as multiplying by 5. 5 times 0.075 gives us 0.150, I think. But double check my work, I'm not sure on that one. Okay, 4 times x equals 17. How do we undo multiplication by 4? We divide by 4. What we do to one side, we got to do to the other. Cancel, cancel. Do 17 and 4 have anything in common? No, so we can just leave it as 17/4 if we want. If you wanted to change it to a mixed number, you could, but this is perfectly acceptable. 5/9 times x equals 10. How do we undo multiplication by 5/9? We can multiply by the reciprocal, so that would be 9/5. What we do to one side, we do to the other. 9/5. Cancel, 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 cancel. We're left with x. And what's happening over here? Well, that 10, since we're multiplying by fractions, we'll turn that into a fraction. 10 and 5 both have 5 in common. 5 goes into 5 once. 5 goes into 10 twice. 2 times 9 on the top gives us 18. 1 times 1 is 1, which just means we have 18/1, which is just 18. 1/2 times x equals 1.5. How do we undo multiplication by 1/2? We can multiply by the reciprocal. Reciprocals are your friends, so flip 1/2, you get 2/1. What you do to one side, you do to the other, which is just 2/1 is just the same as 2, so we'll just treat this as multiplication by 2. Cancel, cancel, we're left with x. 1.5 times 2 gives us 3. 1/3 x, 1/3 times x equals 2/9. How do we undo multiplication by a third? We multiply by the reciprocal, 3/1. What we do to one side, we'll do to the other. Cancel, cancel, we're left with x on this side. What's happening over here? 3 and 9 have something in common. 3 goes into 3 once, 3 goes into 9 3 times. Remember, it only works if the top and the bottom have something in common. and they don't have to be diagonal, but usually they are, but they don't have to be. So now we're left with 2 times 1 is 2, 3 times 1 is 3, x equals 2 over 3. Negative 3 over 4, x equals negative 15. How do we undo multiplication by negative 3 over 4 multiplied by the reciprocal? Negative 4 over 3. Cancel, 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 cancel. Negatives cancel as well because there's 2 of them. Left with x. What we do to one side, we do to the other, so we're multiplying by negative 4 over 3 as well. We'll go ahead and turn that 15 into a 1, or 15 over 1. 3 and 15 both have a 3 in common. 3 goes into 3 once. 3 goes into 15 5 times. And we can also, because there's two negatives make a positive, so we can technically cancel those out too, even though they're on the same line. It works. 5 times 4 is 20, and our denominators are both 1, so x equals 20. 1 through 7 are word problems again. These are pretty long, so I'm not going to bother writing them out, but you can follow along in your book about them. So, number 2, John has A baseball cards, and it looks like just the letter A, but it means a variable in this case. John has A baseball cards until he gave X cards away. How many cards does he have now? So, John has A cards, and then he gave X away. So, what are we doing with that X? Is it adding, subtracting, multiplying, dividing? If we're taking away, we're subtracting. So he has A amount of cards, take away X amount of cards. And that's the amount of cards John has left. And for example, say John had 7 cards, and he took away 2, John would have 5 cards. So that's one way you can put some words into it. So that's just a simple thing. All this question is asking for is J equals A over X. So 1 through 7, the instructions are express algebraically, and that just means set it up like an algebra problem. We get J equals A minus X. Number 4, if 2x plus 1 is an odd number, what is the next consecutive odd number? So if we have an odd number, how do we get to the next odd number? If I have 3, what's the next odd number? 5. How do I get the next odd number? I add 2. So if we have 2x plus 1, just pretend that that's a odd number, how do I get to the next odd number? Well, if we look at our example right here, all we got to do is add 2, so let's add 2. 2x plus 1 plus 2, can we simplify that? Yeah. That gives us 2x plus 1 plus 2. 1 plus 2 equals 3. 2x plus 3. That one, I mean, the wording might be more complicated than how the problem actually is. It's a lot simpler to think about than all that writing they did. But here's a question. How do we know that 2x plus 1 is an odd number? Well, let's take a look at this. 2x. That's always going to be an even number, because no matter what x is, if x is 1, 2 times 1 is 2. If x is 5, 2 times 5 is 10. If x is 4, 2 times 4 is 8. Whenever you multiply something by 2, whenever you multiply an integer by 2, it's always going to be an even number. So if this is always going to be an even number, if we add 1, what's any even number plus 1? It becomes odd. So that's how we know this is an odd number. So that's a bonus for you. Have fun with that. All right, number 6, 3 more than 1/2 of a number is 11. So let's start with the A number. So A number. 3 more than 1/2 of a number. So what's closest to a number? 1/2 of a number. How do we do that? Well, 1/2 of a number of usually means multiple. 3 more than 1/2. So how do we do 3 more than this? Well, add 3. 3 more than 1/2 of a number is 11. Is means equal usually is 11. 8 through 13 are just simplifications. So 8, we've got 6 minus -4. We have parentheses here. We can treat this like distribution. So we can treat this like a -1. What's -1 times -4? That gives us +4. So we just rewrite 6 plus 4 just gives us 10. 10. 8 times -5. Well, let's just start with the numbers first. 18 times 5 gives us 90. And then do we have an even amount of odds or an odd amount of odds? Or negative signs. We have an odd amount, which means it's -90. All right, we got to simplify again. We're always using order of operations. And remember, when we have a fraction, we can treat the numerator as parentheses and the denominator as parentheses. So parentheses, what do we do first? Well, let's start with that 16 plus 2. That's going to give it, and we can rewrite everything we're not going to touch. 16 plus 2 gives us 18, and we can't, the bottom's already simplified, so we can just keep that as -3. Parentheses exponents, 5 squared, 5 multiplied by itself twice. 5 times 5 is 25. 25 minus 18 over -3. And we can kind of treat this like we do before. Because we have two negatives touching, these technically cancel out. And we're left with a positive version of it. So plus 18 over 3. We can only add fractions if the denominators are the same. Right now this is 25 over 1. Common denominator would be 3, so we multiply 25 by 3 over 3. That's going to give us 75 over 3 plus 18 over 3. 75 plus 18 gives us 93 over 3. 93 and 3 both have a 3 in common. It goes into 3 once. Goes into 93, 31, which just gives us 31. And here we have evaluate. Remember, evaluate means substitute and solve. So we want to plug in our values of x, y, and z that they gave us. This is going to be for problems 14 through 17. They're all evaluate. So let's substitute what does y equal? Y equals -1. Replace our x with a -2. And replace our z with a 2. So keep in mind, we're only replacing where the variable sits. So even though there's a negative here, we're keeping the negative. We're only replacing the x with what it says the x is. Same with the y. We're replacing exactly where it was, and it's usually best to put the parentheses. Because this is different than if there isn't parentheses. And I might explain that later. I think I've explained it in another video, but that's okay. Pemdas exponents first. We got -1 times -1, or -1 multiplied by itself twice, which is -1 times -1. Two negatives make a positive. We just got 1. Rewrite everything we didn't touch. Oops. That's okay. We can drop those parentheses. We got a negative touching a negative, which is the same as distribution right there. So we can treat this as -1 times -2, which just gives us +2. And then we got 1 plus 2 plus 2, which just gives us 5. Let me just reiterate, -1 squared versus -1 squared. Right here, the square is touching the whole thing. So we got -1 times -1, which just gives us +1. Over here, the square is only touching the 1. What's 1 times 1? Well, that gives us 1. And if we replace that, we still have the negative that didn't get touched yet. So that makes it -1. So there's a big difference between the parentheses and not the parentheses. And lastly, for this lesson 16, let's do our substitutions. X is -2, x is -2, z is 2, y is -1, and z is 2. So we'll want to do what's inside the parentheses first. So right here we got -2 plus 2. Well, that should -2 plus 2 cancel each other out. So that's just going to equal 0. And then you might be able to tell what the answer to this problem is already, since everything's being multiplied, but we'll keep going. And then over here we have -1 minus 2. -1 minus 2 gives us -3. And we'll do -2. That just leaves us with -2 times 0 times -3. Well, it doesn't matter. As long as 0 is being multiplied, the whole thing's going to equal 0. Alright, that's all for lesson 2.2, practice problems. If you have any questions, let me know. Okay, bye!